Hi guys, and welcome to the channel. Today we're going to be looking at DNS, the domain name system. And we will be looking at ways we can enumerate it and look at ways we can extract useful information. So DNS, the domain name system, is basically the internet's phone book. It turns names you can remember, like google.com, into IP addresses that computers use to talk to each other. So when you type in Google, for example, on your PC, that will make a request to a DNS server, and the DNS server will translate that to an IP address. But today we're going to be looking at subdomains using a tool called Gobuster. So a subdomain would be something like this: mail.google.com. So it's this part before the main domain name makes it a subdomain. Same for something like vpn.facebook.com. Again, subdomain, that part. So we'll use Gobuster and we'll pass it a word list and we'll see if we can detect any of these subdomains using Gobuster. Then once we've looked at subdomain enumeration, we will look to see if we can perform a zone transfer. So each DNS server has a document called the zone file. So the zone file is like a small file, it's like a small book that belongs to a specific domain. So for example, google.com. And inside we'll have details for subdomains and stuff. So we might have mail. Then we'll have the A record, which is the IPv4 address. Obviously, that's not a real IP, but it's just for example. So again, for like a VPN subdomain, we could have another A record. So it basically just lists the mappings to the name, to the domain name, to the IP address. So why do we even need zone files? That's probably a good question. So let's say Google is currently operating in USA. And they have a DNS server and its zone file in America. Then they decide to set up a new DNS server in United Kingdom. The new server needs a copy of all the records so it can answer queries correctly. This is what's called a zone transfer. But usually only trusted servers are allowed to do this, but if it's misconfigured, anyone can request it. So because google.co.uk is owned by Google, they're allowed to request the zone transfer file, or they're allowed to request the zone file so that they can copy the details onto this server. So basically it's copying this file over to here. And that's good, that's the way it's expected to work. But if it's misconfigured, Mr. Hacker down here can request the same file from the server. It's requesting this file, but from this server. And if it's misconfigured, it will be returned to the hacker. We can request the zone file using dig and the AXFR option, which we'll look at in a bit when we actually get into it. But it's just more about knowing the concepts for now, because this can be quite confusing. So DNS, the domain name system, you pass it a domain name, it returns to you an IP address via its zone file information. A zone file contains all the mappings to the IP addresses, but you don't want this file to be accessible by anybody. This needs to be locked down because it could hold sensitive information. It would allow an attacker to map the network. So if a company sets up a new data center or server and a new DNS server, they can request a zone file because they're allowed to, but someone without permission shouldn't be allowed to request it. So I hope that makes sense. We'll get into this. We'll actually jump in the Kali Linux terminal and we'll see this in action. So it should all become a bit more clearer. So if we start with an nmap scan, SC for scripts, SV for version detection, and the IP as usual 10.0.0.4. And we can see 2 ports have come back, SSH 22 and 53, TCP 53 for the DNS. It's running bind 9.18.39, so that's something you might want to check to see if there's any vulnerabilities for that in itself. Okay, so we know we've got that. Let's clear that off. The tool we normally use for DNS enumeration is dig. So this allows us to make queries and other stuff against DNS servers. So for example, if I did it against Google, just the default without any options, so you can see that it pulls back various A records, which are the IP4 addresses. Now if I run it again, it might be different. Yeah, see, we get a slightly different response. This is because Google, obviously massive, has multiple DNS servers. So if we specify NS for the name servers and see what comes back, you can see we got 1, 2, 3, 4. So it could be picking any one of those to retrieve information. So I've set our example up as corp.local as a domain name. So like you'd have google.com, we've got corp.local. The trouble is, if we try doing that, nothing's going to come back because our system does not know what corp.local is. Our system knows what google.com is because we have hard-coded name servers in the resolve.conf file. So name server 8.8.8 is one of Google's name servers, and 1.1.1 is Cloudflare, I think. So when we make calls to, when we do dig google.com, it's checking our system. So then it uses the name server 8.8.8.8, and that resolves an IP address for google.com. So because our test corp.local won't resolve via either 8.8.8 or 1.1.1, we have to specify it ourselves. So we could do corp.local at the IP address of the machine where the DNS server is. So we know it's at this address. That's one way of passing it across. So now it knows where to look for this information via this address. So not a lot's come back. I mean, admin.corp.local, that could be a valid subdomain we want to look into. So we'll come back to this in a bit, the dig tool. Another tool we could use is Gobuster. So we can use Gobuster to find valid subdomains on our corp.local domain. So Gobuster, DNS, our domain, which is corp.local, W to specify the word list we'll be using, and the DNS resolver, which is 10.10.10.4. So that's the address which will resolve the DNS names. We press enter. Just return 2 results. Mail and VPN. Just there's 4 because of the casing. So from here we could run an Nmap scan on that. We'll probably find some SMTP services running or something like that. So that's good, but we could be missing other valid subdomains just by using the one tool. So we go back to dig, attempt to perform a zone transfer, specify an AXFR for zone transfer, pass in our domain name and where to look for it. And see, now that's returned a load more stuff. So you'd never, the odds on brute force in something like dev-stuff, I mean, that's not a hugely hidden name, but hr-files-2025, it's unlikely any word lists have got that in. So that's another finding we want to look into at that address. And this one, at this address, there's another one here, SQL01, SQL database we want to run some Nmap scans on. So the dangerous thing about zone transfers is that anybody can run this against any company. This shouldn't be returned. You shouldn't be able to view this stuff. It should be locked down to only the companies that are allowed to view it. So, for example, if a company set up another DNS server for redundancy or load balancing, something like that, they want to perform a zone transfer so they could copy the existing stuff onto the current machine they've built. But obviously, external entities shouldn't be able to enumerate this stuff, because now, going from knowing nothing about the internals, we've just found all these extra IP addresses. I hope that's made the zone transfer part a little less confusing and easier to understand. And once again, thanks for watching, and I'll see you in the next one.